So let's talk about question 5, which is saying an automobile having a mass of 1000 kg is driven into a brick wall in a safety test. The bumper behaves like a spring of force constant 5.00 times 10 to the power 6 Newton per meter and compresses 3.16 centimeters as the car is brought to rest. What was the speed of the car before impact, assuming that no mechanical energy is lost during the impact or during impact with the wall? So here, if no energy was lost, I want you to understand one thing. An automobile having a mass of 1000 kg is driven into a brick wall in a safety test. The bumper behaves like a spring of force constant 5.00 times 10 to the power 6 Newton per meter and compresses 3.16 centimeters as the car is brought to rest. So meaning that if energy was not lost, meaning that as it was moving, it had kinetic energy. So this is the conservation of energy, conservative of forces. So as it was moving, when something is moving, before it was brought to rest, it had kinetic energy. No energy was being lost. The time it reached, or the time it was brought to rest, at that point it had the elastic potential energy. Kinetic energy is given by half mv squared. Elastic potential energy is given by half kx squared. Now, I want you to understand one thing again here. Okay? So, I can cancel half and I will end up having mv squared is equal to kx squared. The question is, what was the speed of the car before impact? The way it was moving, what was the speed of the car before it was brought to rest? Now I have all the information. It was compressed. X is now 3.16 centimeters. In meters now we divide that by 100. That is my X value. So 3.16 divided by 100. That is 0.0316 meters. What else? The K value we have. What is the K value? 5.0 times 10 to the power 6. What else? We have the mass, 1000 kgs. Now, we want the velocity. Divide both sides by m, here m. V squared will be equal to k over m times x squared. To make v as a subject of formula, I'll get the square root both sides. So v will be equal to the square root of k over m times x squared. If I want, I can use this formula. I'll end up having the same answer. Or I can use this formula. I can say the square root of k over m, then x can be outside, meaning the square and this has been cancelled. Okay? So you can use any of the two, you end up having the same answer. So for this one, I'm going to use this one, the second one. V is equal to, the k value is 5.0 times 10 raised to the power 6. I divide that by the mass, which is 1000. Then times x value is this. So since I don't have space there, so V will be equal to 5.00 exponent 6. Okay? Divide that by 1000. The answer I get a square root. The answer I'm getting now, do times 0.0316. Okay. So I'm getting velocity 2.23. 2.234 meters per second. So now what you are going to follow here, all these things were in 2 decimal places. So I'll leave the answer in 2 decimal places, 2.23 meters per second. That's the velocity before the impact. Okay. So that is it for question 5.